Okay, I'm going to do a problem about shooting a bow and arrow at a target and figuring out how much the arrow will drop on the way to the target. We're going to pretend the person's shooting perfectly horizontal. So here's our guy. And he's got a bad leg there. And he's going to shoot his arrow this way. And on the way to the target, it's going to drop. And it would have gone here if it didn't drop, but it's going to fall this far right here on the way to the target. Now let's make it a fast shooting bow. So we'll say 350 feet per second, which works out to about 107 meters per second. And we'll have the guy shoot 100 feet roughly, which will be about 30 meters. That'd be 99 feet about. Okay, so what we want to do is figure out how much is it going to drop. I'll call that Y on the way to the target. Well, the entire time it's on the way there, it's going to be dropping. So if I knew how long it took to get there, I could figure out how far it will drop. So how long does it take something that's going 107 meters every second to go 30 meters? Well, not a second, because it can go 107 meters in a second. So somewhere less than a second. If you're looking at formulas, our old V equals D over T works just fine. And we want to know the time it takes to get there. So switcheroo puts the V on the bottom, the T on the top. Put in my numbers. I've got 30 over 107. That's meters over meters per second. When I divide that out, I get that the arrow will be there in 0.28 seconds. So it won't take very long at all. Now, for that entire 0.28 seconds, the gravity of Earth will be pulling that arrow down towards the ground. And I have the saying that goes, if you know how long something falls, you know how far it fell, and vice versa. And the equations that go along with that saying are D equals 1/2 GT squared. That's how far something falls, if you know how long it fell. Or if you want to know how long it fell, solve it for T, you get 2D over G. Those are based on dropping, so the initial downward speed is 0. That's why there's no V not T. Alright, plugging in my numbers there, I will get the amount that it falls is 1/2 times 9.8 times the 0.28 seconds that it's falling for. Gives me 0.38 meters or 38 centimeters. So the arrow will actually fall that far on its way to the target.